I hope you all had the chance to listen to the sound of the Martian wind as recorded by the vibrations of the SP seismometers and the pressure sensor. But those are not, in fact, the main way we measure wind on InSight. We have a separate instrument suite called TWINS, which will do that for us. TWINS was provided to InSight by the Spanish Space Agency, and it's the same instrument that's on the Curiosity rover. The general technique for measuring wind is called anemometry, and there are several ways you can do it. You can use a windsock, you can use a cup anemometer, which you often see on modern weather vanes, or you can use a handheld vane anemometer, which is basically a fan on a very low friction bearing. And as these mechanically change, as the wind speed changes, you can figure that out. There are other more subtle techniques that take advantage of physical phenomenon like sonic anemometry, where you send pulses of ultrasonic sound between these different nodes, and as the wind moves through that volume, you can measure its speed. Another technique is called hot wire anemometry, where there are very fine wires, and you apply power to them, and as the wind moves past them, it carries away the heat in the wire. And so you add more power to keep it at a constant temperature, and the amount of power you need to apply varies with the wind speed. What we do on InSight is similar to that with the TWINS. It's a hot strip anemometry, so there's a plane wrapped around the cylinder, and it's the same technique. You apply power to it to maintain a constant temperature, and that power changes as the wind speed changes. So we have two TWINS booms on InSight. They're on these little white truss structures, and there's one on either side of the lander. The lander deck itself will disturb the wind regime and cause turbulence, and so we want the TWINS to be pointing more or less in the direction the wind is coming from, and so we have two to cover the two sides of the clock. We use these wind speed measurements to help tell us about disturbances or noise sources that could affect the seismometer readings, but they also show us cool things like the change of the wind direction with the day and possibly help us detect Martian dust devils.